Hey everyone, welcome back, and in this video we'll solve this rotation problem from Check Your Understanding, Pathfinder. Let's read the problem. So we have a dumbbell that is constructed by affixing of two identical small balls at the ends of a thin light rod. It rests along a longitude on a frictionless horizontal floor. Now a constant force F, always directed towards the east, is applied on one of the balls. So we have to find the maximum tensile force developed in the rod. Let's say this is how north, east, west, south is relative to the plane of the page. So the force is towards the right, which means the longitude running from south to north, or you could say north to south. So the rod would be vertical, something like this. And a force F is applied on one of these balls whose magnitude is F and the force is constant. We have to find the maximum tensile force developed in the rod. So we'll solve this problem taking the center of mass as the reference frame. So the center of mass, first of all, will have some acceleration. Let's call it A. So, and the acceleration of center of mass would be the net force, which is F towards the right, divided by the total mass of the system, which is 2m. So now if we want to take the center of mass as a frame of reference, we have to apply a pseudo force on either of these balls. And now we can assume this center of mass to be at rest. Let's apply a pseudo force. So it'll be, and the magnitude of the pseudo force will be the mass of this ball, which is m, times the acceleration of the center of mass. So this would be F by 2 in this direction. And in this ball, it will be F by 2 in this direction. On this ball, we can just say the force is F by 2 in this direction. So now we can just say this rod is rotating about the center of mass. Okay, so what actually happens is that this force F by 2 is always horizontal. So clearly there will be some angular acceleration of this rod, of the system, and the omega of the rod will increase till the point the rod becomes horizontal. And after that, so at this point, it will have some omega and it will go down. And the moment it goes down, so the moment it crosses the horizontal position, the direction of alpha will reverse, and now the rod is decelerating. Okay, and it will come to rest when the rod rotates by an angle of pi. So we can clearly see that when the rod reaches the mean position, this is the point where omega is maximum. Okay, so let's say the rod rotated by an angle of theta, and at this instant, the force on this ball is still F by 2, and the rod would have gained some angular velocity, let's say omega, and let's say the tension acting on this ball is T. So we can say T minus F by 2 sine theta equals a centripetal force, which is m omega squared L. Now, as you can see, when the rod reaches the mean position, sine theta will be maximum because theta is 90 degree. Also, the omega is maximum, right? So as these two terms are maximum, the tensile force on the rod will be maximum when the rod becomes horizontal. All we have to do is find the omega at the mean position and we are done. Let's try to find that. So the rod is now horizontal. Okay, and let's say the omega at this instant is small omega. So what is the work done by these two forces? So the force is always in the horizontal direction and its magnitude is F by 2. And the displacement of this ball in the horizontal direction is going to be L, right? So I can write the work done by the force as F by 2 multiplied by L. And the work done by this force F by 2 on this ball will be exactly same. So I can just double it. And this would be equal to the increase in kinetic energy of the system. And that will be half I about the center of mass, which is 2 ml squared times omega squared. And from here, we'll get the omega. We'll get the value of ml omega squared as F. Let's call it equation number 1. Do is write the force balance equation for this mass m. So the tension on this would be T and the force is going to be F by 2. So we can write the net inward force, that is T minus F by 2 is the required centripetal force, which would be ml omega squared. And now ml omega squared is F. So we'll get the value of maximum tensile force to be 3F by 2. So that was it for this problem, guys. If you enjoyed the video, please like and subscribe, and thanks for watching.